Hello friends, welcome to civil engineering exam. Today we are going to see the problem related with soil mechanics in the topic of slope stability. So the problem is analyze the slope of one question is there. So in example 10.3 the alpha value is 25 degree. So if it is made of clay having C equal to 30 kN per meter square, that is cohesion equal to 30 kN per meter square, then phi angle of internal friction is 20 degree, then E void ratio is 0.65 and Gs, that is specific gravity of solids, is 2.7 under the following condition. So the first condition, when the soil is dry, so the soil is completely dry, so the gamma value will be gamma D. So then the water seeps parallel to the surface of the slope, so it having some water content, and when the slope is submerged, so the gamma dash. Okay, so here is the gamma saturation. Okay, so now the solution for E equal to 0.25 and Gs equal to 2.7. So we have to find out the gamma D value. So gamma D equal to, so formula is G into gamma W divided by 1 plus E. Okay, so now we can substitute all the values over here. So G is equal to 2.7 into gamma W value is 9.81 divided by 1 plus E value is 0.65. Okay, so solving this, we got the value of gamma D equal to 16.05 kilonewton per meter cube. Okay, so next thing is gamma saturation value. So gamma saturation equal to G plus E into S into gamma W divided by 1 plus E. Okay, so now we know that in saturation condition S equal to 1. So now G value is 2.7 plus E value is 0.65 into 1 into gamma W value is 9.81 divided by 1 plus E is equal to 0.65. Okay, so now we got the value of 19.9 kilonewton per meter cube. Okay, so next thing is gamma dash. So gamma dash equal to gamma saturation minus gamma W. Okay, so now 19.9 minus 9.81. So now we got the value of 10.09 kilonewton per meter cube. Okay, so this is the gamma submerged value. Okay, so now we found out three unit weights for the three conditions. Okay, so now we can take the first condition. So when dry soil, so the backfill is dry, so now the stability number NS or SC. Okay, so we can denote NS or SC. So equal to, the formula is cos square beta into tan beta minus tan phi. Okay, so now we can substitute the values over here. So now cos square beta value is 25, so that is alpha value is 25 into tan alpha value is 25 degree minus tan phi value is given, that is 20 degree. Okay, so solving this, we got the value of 0.084. Okay, so now the for the Taylor stability number is 0.084. Okay, so now the critical height, so the HC equal to, the formula is C dash divided by gamma D into NC. Okay, so or NS. So now we can substitute all the values over here. So gamma dash, sorry, C dash equal to 30 divided by gamma D value is 16.05, we found out, into NS value is 0.084. Okay, so solving this, we got the value of 22.25 meter. So next thing is seepage is parallel to the surface of the slope. So now the equation is NS equal to cos square 25 degree into tan 25 degree minus 10.09 divided by 19.9, that is gamma submerged divided by gamma saturation into tan 20 degree. So 20 degrees, phi is angle of internal friction. So now we got the value of 0.2315. Okay, so this is the Sn or Ns value. So now stability number value. So now we can substitute Hc equal to 30 divided by, so gamma saturation 19.9 into, so we found out the Sn values, Ns values 0.2315. Okay, so now we got the value of 6.51 meter. Okay, so Hc value is 6.51 meter. Okay, so next thing is for submerged slope. So for submerged slope, so for submerged float, so now Ns equal to cos square 25 degree into tan 25 degree minus tan 20 degree. Okay, so now we got the value of 0.084. So this is already we found out 0.84 over here. So now we substitute the value Hc equal to 30 divided by submerged values 10.09 into 0.084. Okay, so now we got the value of 30.5.4 meter. Okay, so now we found out all the critical gradient in the three conditions. So first thing is 22.25, so second thing is 6.51, third condition 35.4. Okay, so this is the method we can solve the problem. Again, we'll see next video. Thank you.